So that's why you see that actually the timing here as in 10 p.m. EST, because I'm on the East Coast of on the there are three time zones basically. So I'm on the East Coast of the time zone. So now actually, having said right, I am doing up in a Snowflake actually from last 3 years. So from last 3 years, I'm implementing in a Snowflake with multiple clients. I have implemented it, right? I've taken up the multiple sessions as well, trained multiple peoples on the Snowflake, and that's where like I'm being going to teach you, or maybe like I say, we will have the interactions on your learning journey for a Snowflake. So that's how we will be going to have. All right. So this is just a brief about myself. Would like to know more about you guys. Can you tell me about yourself? We can start with one person. Hi. I only see me. Why don't I see others? Actually, is there something that I need to do that?
Sir, two persons are joined, sir. Kumar and Ganesh.
Actually, it's not showing it. So, okay, yes, now I can see that. Sorry, my bad, guys. Actually, just still be learning with this meeting seminar tool, right? Actually, not used to it. I used to give it on either on Zoom or mainly on the Zoom, basically. So, Kumar, right, how are you doing? Can you just briefly tell me about yourself and your experience, right? And why you want to learn about a Snowflake, Kumar?
Hey, hi. Actually, I'm not a data engineering background. So recently, I got a job in data engineering, and my company is trying to switch from data IQ to Snowflake. I mean, the a big data to Snowflake environment. So yeah, so I'm trying to learn how the Snowflake works before they get it Snowflake environment in place. And also, I mean, I don't have much knowledge on SQL as well, as I'm not data engineering background, and so I'm not sure like how easy to learn this technology to continue on data engineering in the future. So I thought to join a session and see how exactly works this tool, and then thought to continue on that.
Okay, so Kumar, if may I ask, right, what was your technology background?
Mine is ServiceNow. So
okay, great.
yeah,
that's a great technology, because I love ServiceNow. All right, but good to know that, right, that you worked on ServiceNow. Okay, we will talk about it. All right, actually, I know ServiceNow uses a database at the backend right now.
Right.
Okay, and they are talking to move their database to Snowflake. Okay, so ServiceNow is also moving to the Snowflake. We had some connect with the ServiceNow folks last month, in not even last month, in November, and that's where like they told us that they are planning to move their database to the Snowflake, and they're also evaluating the Snowflake as their one of the options. So definitely, that's a technology for the future. Now, give me a moment. Let me just also talk to Santosh. Hi, Santosh. Could you just give us a brief introduction about yourself, and why would you like to learn Snowflake? Santosh, if you are speaking on the mute. I think like Santosh doesn't wants to talk to us. It's okay. Okay, so Kumar, actually, good. Like actually, you know about a service now, right? You knows about the rules, right? Actually, how, or maybe like actually you are from the Java background on the service now. You might be using up a Java or even a .NET, right?
JavaScript.
Yeah, JavaScripts, love it, man. Actually, then Snowflake is no different, right? If you know the JavaScript, you can easily cope up in Snowflake, right? Only thing that we require to know about it is SQL, but SQL is not very difficult in terms to understand a SQL, right? It's a structured query language, as the name says, right? Actually, it's SQL, right? What we do it is, right, we need to know about the database concept, right? And then it's all the common way how we speaks, right? If you say that, hey, the database has the tables and the rows, right? That's all the same thing. The concepts is being now moved from an on-premise database to the cloud. Now that's what we will be going to talk about in the Snowflake. Okay, so in this session, what I'll be covering is I'll be giving you a high-level overview about the Snowflake. Okay, because this is a demo, right? So I'll be telling you about the Snowflake, right? And what makes it been distinct from the other technology. But since you've been from a ServiceNow background, so I'll bring it up that how does it works basically at the back end, all right? What things has been done at the back end to make this been, and what is the underlying architecture of a Snowflake? What makes it been distinct from the other databases? If you don't know about a databases, no worries, we will learn it, because this is what the journey is, right? We'll be going to talk about the databases, we're going to learn about the databases, right? And we'll train you up so that when you will be going in your job, you'll be prepared for that. Okay, so let's take it a step further and see that what a Snowflake is. Okay, sorry.
Okay.
Now let's see. Actually, you've been using a service now for a long, right? You've been coding up in JavaScripts, but all the data has been stored it up somewhere. You're storing that data in a database, which is in the on-premises, right? And that on-premise database has to be scalable enough, right? And faster enough to give you a quicker results, right? Let's say, like actually today you've been handling up and 10,000 RATMs or the 10,000 requests on a day-to-day basis, or ServiceNow incidents on a day-to-day basis, which you've been logging, right? Maybe more than that. You might have configured your end system to handle these many number of requests. You have the servers, you have the memory, you have the disk as well to write it down, all that information. You've been creating up the forms, and this forms is collecting up an information. This information is going to return into some form of a database, maybe into an NoSQL database, which is kind of a document, right? I think where this information is going to be stored. Now, what makes it all works is your platform. You require a platform, or you require a machine. You can say that a computer, right? Now, how if our computer is been limited to an particular size, right? Our possibility of reading that data or writing that data will be limited to that particular computer size, right? Let's say like your computer is having 16 GB of RAM, right? So you can do an X number of processes faster on that. It means like on only an X number of processes that can run. What if tomorrow the requirement changes and your data is started growing? Right, that's where like the big data is. When we say that, hey, big data is, we are using up a big data, right? And big data is all about the 3 V's, means the velocity, the variety, and volume, right? The velocity is by which the data is coming. All right now, for let's say like I get 10,000 RATMs on a day-to-day basis, right? New users has joined, the business has expanded, mergers happens, right? The RATM volumes or the request volumes has been increased to 15,000, right? And now actually my underlying system it has to handle it. So my volume of the data volume is getting increased, right? Now actually this volume of the data also only led me to increase in the variety. Now let's say like actually what is the variety of the data, right? So far now we'll be getting it up all the data into a JSON format. So actually JavaScript is good enough to handle a JSON. Let's say tomorrow, with the evaluation of the technologies, right? Actually the XML data is also coming in, right? XML is the first language, markup language, which has been used for sending up or storing up the web pages and all, right? HTML was there, but again, XML gives us a different opinion, and this XML can be stored into a databases as well, right? And we can query the data from this XML, right? So that's the variety. All right, you are now getting up in different kind of a data files. The data files is like uh, an IoT data. Let's say consider an IoT data, right? You have a car, right? You are going with a car, and your car has some of the sensors in it, like reverse parking sensor. Taking example, right? You are reverse parking of the car. Then what did you analyze it? That if there is any car coming from the back, you will be notified, hey, actually there is a car coming. That's a sensor. Now, what if we start collecting that data, right? Then actually there may be a different way from which that data might be coming, that IoT data. It might be coming it into an Parquet file, maybe a JSON file, maybe XML file. So data is no longer a structured, right? It is called as a semi-structured data. Why? Because it doesn't falls into a structured category of rows and columns. It falls into a semi-structured category. Right. Now let's talk about the semi-structured category. So there are multiple file formats comes in that. What are the file formats in that? There are Parquet files. What is Parquet? Let's say Parquet is the file that was developed by an Hadoop, a big data appliance, right, for storing their data into a columnar format. Now another term, columnar format. Okay, don't get stressed out that, hey, actually, what is this columnar is? We will come to that. But let's say for now, these are the different uh, types of the files in which the data is stored. Right now, we are moving this data to an X system, which is from Hadoop to the Snowflake. So we'll talk about the movement as well. But for now, we talks about volume, variety, the volume of the data, right? He talks about the variety of the data, and what was the other V? Is three V's are there, right? We talked about three V's: the volume of the data, the variety of the data, and I think I might be missing up. What did I say?
Velocity.
Velocity of the data. Super. So what is the velocity? Right? Let's say like in we are using Vodafone. Okay, I was also using up a Vodafone. So Vodafone has a 3G tower when I was using it. Now it's 4G. Even in fact 5G is also coming, or maybe there. I don't know. I've been not to India, but I know like the 5G is also there. What does the 5G do? You have a lot of devices, right, from which the data is coming. Now actually, how quickly this data is coming in, we need to do an analysis on that data. As soon as the data comes in, I need to do an analysis, right? It should not be taking me a longer time to process that data, right? So that's where that the third V comes in, where the data is being coming up with so much of right, the data which has been arriving to us, right? It is in so much speed, means like speed of data is so high. From the multiple devices these data are coming, right? Every time I go and log in into the system, there is new data. So same thing, same example, right? Actually, when and system expands, right, or the mergers happens, right, in the companies. So there are the new RATMs that is going to log in. So earlier I have 10,000, now I have 15,000 of RATMs which has been logging. So that's how actually the data has been increasing, right? Actually, the data volume has been increasing, right? So now actually these three V's contribute to the invention of Hadoop systems. Okay, because the Hadoop, why was the Hadoop being implemented? Because there was an it's an open source first of all, right? Somebody or people like you, me, and other people's like actually they get together, they decided it up like there should be an open source system or open source technology, right, that should be used to develop it up, and language that should talk to each other, right? And then these languages was then taken over by and companies like Cloudera or Hortonworks and developed their the particular data suites or the ecosystem, I can say, not the data suites, the ecosystem, right? And now the major advantage what the Hadoop has it is because of the commodity hardware, right? Actually, in my days back in 2005 or 4, right, when we used to go to buy the laptop, it was so damn expensive that we can't afford the laptops, right? It was the desktops. Actually, I used to have that, and that desktop also used to cost 30,000 rupees. Now, actually, if we and the hard disk size was 40 GB, right? 80 GB. That was at max. We had that, right? And RAM 256 MB. Now with the invention of the new technologies and all, right? The RAM, now we have one single DDR4 RAM of 16 GB, even 32 GB of the RAM on the single DDR4 slot can be attached, right? We can have 1 terabyte of hard disk, right? So this is all because of the expansion of technology, right? With the technology, the things are getting being made in the faster way as well, but the things are getting cheaper as well. So that is called as a commodity hardware, right? So Hadoop uses the commodity hardware to install their own software and then deploy all the services that will use that will provide us this all or satisfy all three V's. Now, when the cloud evolution started, right? And the cloud evolution started sometime in 2003 from an Amazon, right? Azure was not the first cloud that came in. Amazon was the first. There was two people in the Amazon, those who have presented a paper for the services which can be deployed on a cloud where you don't need to worry about managing the hardware and all, right? And that's how like the Amazon has spent a lot of money and they have taken this forward, right? And developed the cloud services, right? In 2009 they have come up with a full-fledged cloud services called AWS, Amazon Web Services Cloud Services, right? So that's the time, right? They started putting up. Now actually by the time the system got matured by 2017 and 18, cloud is predominantly being used by many organizations, right? It is like as a boom. Why? Because you don't have to worry about managing the CPUs. You don't have to worry about going and purchasing the CPUs. You don't have to worry about putting them. It is not going to take any space on your or data center, right? You don't have to worry about the maintenance of that. So all this has been done and handled by the cloud service provider, which is here in our case AWS or Azure or GCP. These are the main three cloud service providers. So now Snowflake also understand this concept. So the persons, those who have founded a Snowflake, they were earlier working with an Oracle. Oracle is one of the most selling OLTP database, right? Actually, or I'll say that everybody in their school or college life must have known about the Oracle. Have at least heard about it, Oracle. I'm not saying like you have worked on it, but at least you might have heard about Oracle, right? Because Oracle was the company that establish out the database, right? It is not like it was the first company. There was the company before that as well that was making up a databases, but then Oracle made it available to every single organization, every single business unit, right? You can store your data into and columns and rows. What is columns? What is rows? You see the Excel sheet, right? Simple. We are writing up a data in an Excel sheet as in like one single row, means a one row and it can have n number of columns. So you can define 10 columns, 15 columns. Now this rows and column contribute to an entity, right? Now what is an entity is a logical term. If it talks about on the database side, it is called as a table. Okay. Now you can deploy the tables, you can create the tables, right? That's what in the database you do it to store your data, right? You can have n number of tables, right? Or I can say that n number of sheets, Excel sheets to store your data into a row and column format. Now, underline, how does it being storing it? It's just storing that data into a file system, right? When we talks about a file system, so let's say that there were FAT32, FAT32. I think like if you guys are working on Windows, you very well knows about a FAT32 file system, right? Or NTFS, right? So these are like the file system. So Snowflake, Oracle has their own file systems as well. Now, actually, that's how they have defined it, that how they will be going to store the data, right? And for accessing that data, there was a query language that was developed that is called as a SQL query language or structured query language, SQL, right? that will have, you can write down a statement in that and it will get the data for you. Like select, what is select? Select means, hey, I want to look for some data. I want to check some data. So what do you call it? Select. Then what do you want to check? I want to check a column A, column B, column C. That is that you are mentioning the column names. What say if you don't know the column name, what will you do? You will put star. Star will, like how we will search, right? Star. So we put a star, it will give everything. So all the columns in that table, it will give all, right? Select a star from table and then you will say that, hey, actually, I want to fetch it up a number of records, XYZ, whatever. We will talk more on that. But then actually when this all, the Snowflake takes this all to the cloud. Why? Because now the cloud has the same architecture in terms of the commodity hardware which has been available on cloud. Now, no maintenance, right? No space taking, right? No right, overhead, or actually pay as per you use, right? That is the main concept about it. Now that's what the Snowflake gives, right? They take their databases from an on-premises database. Like you don't need to have a server, you don't need to install the software, you don't need to worry about taking up the backups or anything. They take everything to the cloud, and that's where the Snowflake is gaining a popularity, because that's what make it distinct from the other data warehouse which is available in the market, right? So now another thing on that is the distinctive architecture, right? The Snowflake has a very unique architecture, right, which makes it distinct to for an end user's perspective. Let's say for an end user, if I say that, hey, actually, Kumar, you have one computer, right? One computer, 16 GB RAM. You are running up your extreme high workloads, right? It burn up. What if your workload is increasing? What if you will attach another computer to your existing computer, right? On the fly, will it not help you to ease your workload? Yeah, although you are working, you have to work on that, but actually your compute is being increased. Now you will have another an i7 processor with 18 or with 16 GB of RAM, right? So actually the work which you are performing, it can be scaled to the another CPU or another machine, right, which can share the resources. So when it will be sharing the resources, yeah, you will not be burning up your one single computer. Or let's say like I have multiple workloads, it will not wait. Like in the shopping queues in the supermarkets, right? We go to the super centers for shopping. What we do is, right, we wait for our turn, right? And once we'll get our turn, then actually the person will scan the items which we purchase. But think of it as then, like there are multiple empty scanners, right, actually placed there. As soon as they see that, hey, actually the queue is building up, means like there are 2% in the queue, it will be open, and you both can go and perform your jobs parallelly. Means like the person, you and the person behind you, you don't have to wait, right? So the resources can be quickly, or the faster resources can be created. Now, having said this is basically about the how the Snowflake has been increasing up their the compute, right, and the also the memory. Now the compute and the memory is not something which has been tied together, right? So or not, I'm sorry, I should say the compute and your hard disk, right? That is not something which is tied together. So you have an unlimited space at the back end to write your data, right? You don't have to worry about writing your data saying that, hey, actually I'll be only be able to write 10 GB of data, 15 GB of data. You can write hundreds of terabytes of data without having worry about the space. How that is made possible is with the underlying technology which Snowflake is using. Snowflake is using S3 or a blob storage or a Google Cloud storage at the backend for writing these data. and the data has been written in the Snowflake proprietary format in these buckets, right? Now, actually, the compute is the main limitation. So what does a Snowflake did it? It has created up a multiple computes for doing up a multiple workloads. What is a workload? Right? Let's say like actually you are running and let's say right now Kumar has mentioned it. He is being doing as a data engineer. Right? So now actually there are 10 data engineers like Kumar is been hired by an organization, right, for the same project. Now, actually, but those 10 data engineers have a different skill sets. Kumar has a skill set of JavaScripts, others have a skill set of Python, one has a skill set of Scala. Right? These are the other languages, right? Now, actually, they all want to work on the set of data. Let's say like Kumar is working for a telecom company, right? Kumar has been given up a data to find it out a churn analysis. What is a churn? Like actually the users who's been switching it from one subscriber to the another subscriber, and what is the reason they are switching it? How the users can be retained, right? So that is something like we want to do and understand like the churn analysis to find it out. Like, hey, actually we want to know who has been leaving and who is been coming and who. So how we can retain the persons those who are leaving. Okay, so now actually Kumar is developing one program on JavaScript. With Santosh is also developing one program. Anshul is also developing one program. We all parallelly are developing a programs on the JavaScripts. So now actually when we talk say that hey we are developing a programs, what we need is a compute. Okay. Now actually the compute, from where does the compute comes? The compute comes from the Snowflake. The Snowflake is going to give us the parallel computes. That's what makes it work, right? Actually, you don't have to wait that hey, actually Kumar is running his jobs first. Let's wait once Kumar finish, then actually Anshul runs. Once Anshul finish, then Santosh runs. Not like that. It can run parallelly. You can create a multiple parallel workloads. Those are called workloads, right? Now the other factor is right. Kumar is working for let's say right Vodafone. I'm working for an Airtel. Santosh is working for Tata, right? Actually, and they all wants to share their data. Right? How can it be possible? Because they might not be talking up on the same language or the same level, but underlying they are collecting up the data, right? And they are transforming that data. But what if they all are using a Snowflake, right? It is very easy to share the data with a Snowflake. You don't have to move the data around. You don't have to create a job or write a data engineering job like a Python script or something like that to extract the data or send the data. I don't have to write a script to extract my Vodafone data and send it to Kumar. Right? Kumar don't have to write it down same thing for me or sending it to Santosh like that. So that is possible because of the seamless connectivity with the databases, right? How is it been made possible? We will see in the coming slides. Okay. Now, actually talking about the platform, what is under the hood of the platform, right? So the platform can be used for your data engineering, right? It can be used for your data lake, can be used for your data warehousing needs, actually. And then your data science needs, your data application needs, and your data sharing needs. Now, these are the different kind of workloads, right? What under the hood is been working is performing, giving you an elastic performance engine, right? And an intelligent infrastructure and a snow grid. We will talk each one of these, right? What are these? But before that, we also would like to know that, hey, actually my data sources, what could be my data sources? My data sources is my OLTP databases, like the ATM machine, which is running on an OLTP database, right? And enterprise applications, right? Like the ServiceNow, which is an enterprise-wide application, right? Any other third-party application, any web logics or applications which is generating the logs at the backend and running it up like the cell phone towers, right? Then and any IoT applications, which is a sensors-based applications, right? They all will be generating the data now. And who will be the consumers, right? Who wants to monetize that data? What is the monetization? They want to uh, create a value out of that data. How they can create a value out of that data? By writing some algorithms, by writing some queries, by writing some programs, which will tell them, hey, actually, how you can use this data for generating your revenues, right? So you're using the data to generate the revenues. That is called a data monetization, right? You can use it for operational reporting. What is an operational reporting? A dashboards, right? Where you will create it and say that, hey, actually, this system has been not working properly. This system has been down. These many requests I got it. These many requests are completed and all, right? So how we do it on the service now, right? We prepare a dashboard. So actually, these are kind of an operational reporting. Then some ad hoc analysis. Let's say like I came in and I say that, hey, I know that actually I'm getting up with too many incidents. What I would like to know that is why there are too many incidents coming up. What's the reason? Do we have the information to find it out? Yeah, we have a data where the people are logging that, right? Or where the incidents has been auto-generated or auto-logged, right? So we can do the analysis and find it out that why is it being. So those are kind of an ad hoc analysis. Then some real-time analysis. Real-time analysis, like, oh, actually, I'm sitting on an airplane. Airplane is going to land, right? But there is a bad weather, all right? And all of the sudden, there is a high winds that have started. Although, like the pilots will get to know from the what you call is a flight control tower. All right, actually they will inform it. But what if they will be having a real time information coming in form of weather application, which is connected to the flight information system. All right, actually, or maybe like let's say if I want to give them an information saying that, hey, actually there's a heavy storm, right? We will land it, but there's a heavy storm in the city. I want to give that information to my end users, those who are in the flight, right? And if that information can be provided with the integrated with the weather app, which says that, hey, actually, if you stay in the storm will be there for at least 1 hour. After 1 hour, the storm will be clear up, the clouds will be clear, the sky will be coming out, and the sun will come out, the sky will be clear. So all this information can be coming through in real-time analytics, right? There are many more other examples. Now, for running all these services, which a Snowflake is saying, right, we require an infrastructure. Who is providing that infrastructure? Now, there are mainly three providers for that infrastructure. One is Google Cloud, right? Another is AWS, and third one is Azure. So only these are the cloud infrastructure providers which we can use. Now, it's up to your organization or you to decide it which cloud services you want to use it. Snowflake is been available equally on all three. All services are available equally on all three. Yes, Google has very few regions. AWS and Azure has wide regions, means like wide presence in the world. They have multiple regions. So I'm not talking about the reasons. That is something very a different topic. But AWS services can be available anywhere. All right. Similarly with Azure, because they have the infrastructure deployed there. Right. Google has limited. They are expanding, but still be a limited. Right. But that does not mean like Snowflake will not work on it. Snowflake can be deployed on AWS, Azure, and Google, anywhere.
One question.
Yeah, go ahead.
So to work, to have the Snowflake environment, so definitely we should have any one of the cloud service like Google Cloud, AWS, or Azure. Without that, Snowflake won't work, right?
Okay, now actually, Snowflake does not say that you need to have these services. If you have any of these services, Snowflake will go and deploy their instance on that services. Right? Let's say like your company is already using AWS, and a Snowflake will come and say that, hey, actually you are already using an AWS. Let me do one thing. Let me provision an a Snowflake AWS instance for you in a particular region. Right? Let's say you are using up a Mumbai region. So they will come and deploy their services in the Mumbai region. If you are using up an US East one, they will deploy the services in the US East one. Right? So that way the services can be deployed. Now, Snowflake does not recommend that which cloud services you should be using. Snowflake says that, hey, I am available equally on these three. It's your choice, whatever cloud you are using. If you're not using, again, you can make your decision and we will come and deploy our services on any of that cloud services.
Okay, so that means definitely, I mean, to have these Snowflake services, we should have one cloud technology for sure. to deploy
Yeah.
their services on those instances. So I
So
mean,
you don't need cloud services. That's
mhm,
what I'm saying. You don't need a cloud services, right? Let's say like actually I don't have a car. That does not mean I cannot drive it, right?
mhm.
I can go and take a car on a rent and drive it, right? Because I know the driving. So that's what a Snowflake says that, hey, actually you don't have a cloud, don't worry. Okay. Hey, if you have any choice, you say that, hey, I have a choice of AWS, but I don't have an AWS instance, right? Snowflake says that, okay, what region you want to be in? You say that, hey, I want to, my data is been localized to the Mumbai region. I don't want that data to be go outside of India. So Snowflake says that, don't worry, we will deploy your our AWS, Snowflake instance on Mumbai AWS region, right? And
Okay, one
they
question.
can,
Sorry
yeah,
to disturb.
yeah,
Sure. Yeah, so I mean, my understanding is like I understand like okay, they are not giving any option, like it's up to the customer choice to have the any cloud service, but
mm,
still to deploy those services, they should have any one of the cloud service.
yeah,
That's my understanding. But my
yeah,
question is like, let's say you're having the on-premises database like Oracle or MySQL or something like that, so you
mm,
don't have any AWS technology. So can we
mm.
have Snowflake instance without having any cloud technology? And can we connect directly to the Oracle database and pull the data back into the Snowflake? Or do we really need to have any cloud technology, though we need to pull the data from Oracle database?
Yeah, you need, why? Because you know, right? Actually, a Snowflake is nothing, just a software, all
Oh,
right?
okay, okay, got it.
Right. Oracle is just like a software, but it needs a hardware as well, right, to run it. So
Mhm.
Snowflake also needs a hardware. So hardware, where does it come from? From these cloud providers. Snowflake will take these hardwares from these cloud providers. So
Okay,
Snow,
but then
yeah,
how will I mean we are storing the data in Snowflake database and everything. It's still we are deploying on the cloud. That
yeah,
means in the background, AWS is a database, the cloud database. So if we are storing the data into a Snowflake, that means on the back end we are storing the data in the AWS itself, not on the Snowflake, right?
yeah, yeah. Actually, Snowflake is just a services, right? It's software as a service. At the back end, it is using up the infrastructure services or the platform services provided by AWS or Azure or Google Cloud. So now actually AWS can provide you n number of services. Right now they have 91 services up and running, right? So you can have virtual machines, which is like your VMs, or which is in terms of AWS is called as an EC2 instance, Elastic Compute instance. Then you have your hard disk, right? SSD hard disk. You have your blob storage. So now there's a difference between an SSD and blob. Why? What is the difference? In an SSD storage, you can store the operating system, right? But you cannot store an operating system into a blob storage. Why is that? Because a blob storage is an object-based storage, right? So object-based storage will store, or blob or S3, right? They will store it as a file, single files, but they cannot store it up the complete um, uh, OS as a one, right? Actually, because the OS is comprises of multiple files, so they cannot store that, right? So that's why a Snowflake is using blob or a S3 at the backend for storing that data. Now, okay, this is all now we don't have to manage these all infrastructure. This is all managed by whom? AWS. And how are we paying for it? We are paying it for what we are using it. Let's say like I'm storing up a file, right? My files are getting more than 23 terabytes, right? So Snowflake says that, hey, actually you are storing up a file. We will charge you per, on an average per month basis, right? We will charge you up, right? Our charges is 1 terabyte for 1 month, right? If your storage size is 1 terabyte for 1 month, we will charge you $23. Right? So there is a flat rate for the storage, right? If you are using up 23 terabytes on a month, it will multiply it by 23, and that's your monthly storage charge. Now coming to your compute, right? You don't have to spend in normally, or when we establish an Oracle system, what we do, we go and purchase an Oracle capacity in the starting, right? We'll say that, hey, actually I need it up in this much rack, right? 4 racks node, 4 rack system, right? Which is each rack is having 16 in earlier it used to be 16, but now actually it should be more than 16. It can be like actually 8 processors, right? 8 processors and 108 gigabytes of memories, something like, right? So that's what an Oracle one rack is about. So we have 4 racks, so 8 into 4, 32 CPUs, and 108 into 4, that much RAM. But RAM and the CPUs cannot be increased if your data volume is increased. Data is being stored on SAN, right? So you will be storing your data on the SAN disk, where you'll be writing up all the data, which is being connected to all the 4 racks. But now, actually, if you have to put it in another rack, or you have to extend it, you have to purchase another capacity. Not in the Snowflake case. Snowflake, you can extend it, right, without having to pay for an additional cost, because Snowflake says that we will charge you what you use. So what is it about? Snowflake says that we will charge you credits, right? One credit in a Snowflake term is equals to $4. Right? Generally, when you get into a negotiation, it can come down from a $4, but right now one credit is equals to $4. And how does the one credit is consumed? Consider that as your gas tank, right? So if how far you will go, you will consume the gas in your gas tanks, right? Similar way, the Snowflake say that if you go for a extra small warehouse, which is 1 CPU and 8 GB of RAM, right? If you use that for a 1 hour, we will charge you one credit, means $4, right? If you use it up, and now Snowflake has divided the compute into a t-shirt sizes. You will see that as well. But for now, actually, does that help you answer your question? Right, how we will be comparing up a Snowflake with Oracle?
Yeah, I got it.
So let's move on, right? We will talk about the Elastic Performance Engine, what it do, how does it been different, right? So now at the center of the Snowflake is the compute. Now let's say, like, if I have to go to the party, I use that example because I can correlate it. I have a big family, right? I have cousins also, and everybody comes together, and then we will go. So now, actually, if we will go, either, right, everybody has their own cars. Our destination is same, right? But everybody has their own cars to go. Now, actually, every cousin have their own family as well. But our starting point is same, and our destination is same. But we are using our own cars to go there. Sometime we will do the pool. Like, I have a big van where I can take up 10 members, right? Actually, like, and elder people, right, who can't go by themselves, right? So we can pool that. So that's the same way Snowflake also do it. Snowflake says that, hey, we give you a capability to create your own virtual warehouses. What is virtual warehouses related to here is the cars. The Snowflake provide us the capability to create our own cars on the fly as when needed, right? I have and 3 cars at home. I have 3 people who will be using 3 different cars. Me, I'm using one, and my brother is using one. My father is using. So they have 3 cars. They are using 3 different modes, right? Actually, now coming back to the Snowflake. Let's say, like, if there is another cousin of me has come in, right, and then he said that, hey, actually, we also wants to. I also have a car. I want to park my car and I want to go for my institute with the car. Okay, no problem. You have your own car. You bought your car. You park it here. You use it, right? The same thing as Snowflake also did it. It will create up a multiple computes and give those computes to the individual workloads. Now let's see that here. Now, a dev and a QA, right? What does a dev and QA do? There's not much workload on the dev and QA. We created up a one warehouse for dev and QA, right? And give them a nodes. So we created up a 4-node warehouse. What is a 4-node warehouse? Now, actually coming on also on the size, right? We will see that how does the size works in a Snowflake. But for now, let's say like they want a 4 CPUs for their workload and a 32 GB of RAM, right? So I created up a 4-node warehouse for that and give it a 4-node extra small warehouse and give, or let's say not extra small, let's say medium, right? Because the compute sizes multiplies with the t-shirt size. We will tell you as well that thing. But for now, I created up a dev warehouse with the medium size, one dev warehouse with the medium size, which will be 4 nodes, consist of 4 nodes. Now, actually, one node equals to 1 credit, right? If it runs for 1 hour. So it now actually I have clubbed it 4 nodes and created up a one cluster for that 4 node. That cluster is called as a medium size cluster. Right? So I cannot say that, hey, actually I'll be segregating one cluster from it and I'll be using one. No, actually that will not happen. So you need to create up a separate cluster. Now, similarly for an ETL process, what is an ETL? It is an extract, transformation, and load process. I created up another cluster, right, and given up and cluster again of 4 nodes, right. For BI visualization, I might require it up and a smaller cluster, right. I don't require it up a big size warehouse or big cluster, right. I created up in a small cluster of a small size, right. Similarly for data science, right. So this is like how you are creating and adding up a multiple CPUs, right? And you are creating up a nodes out of those or cluster out of those CPUs. Right? So that's what a Snowflake is doing it. So how does it they do that? They are using at the end VMs, virtual machines. Right? They have the capability to create a virtual machines on the fly and assign it to you, right? And you can use that virtual machine. So they have a dedicated capacity assigned to them. Now, when we talk about a dedicated capacity, what is that dedicated capacity? Nobody knows, right? They have an arrays of CPUs, right? Let's say, for example, they have 10,000 CPUs available only for a Snowflake compute. You don't know that. Neither does a Snowflake will tell you, neither does an AWS or Azure or GCP is going to tell you. But they have an agreement that whenever the capacity is needed as a term of compute, it will be available to the Snowflake. Okay. See, now, second thing, actually, you don't have to be wait for your turn to execute the process because you have the different capacities now. Okay, so there is no longer a one engine for means like or I'll say that a restriction on the engine, right, or the compute. I have the more compute, I can do anything, right? Now coming on to your or concurrency. This will also helps me achieving up a concurrent workload. Means like my BI visualizations, my data science, my ETL, my dev and QA all can work in parallel, right? Nobody has to wait for the resources, right? Because everybody have their own dedicated cars, right? Means like my all cousins and my all family can go together to the party, right? They don't have to worry about waiting for a car or waiting for a space because they have their own cars, right? That's what Snowflake doing. Now coming on to support for what has been supported here, it is supported with a native SQL, right? Anybody who knows about an SQL can do it. Let's say like for our case, Kumar does not have a very good background about a Snowflake. No worries, Snowflake is not different, right? You know Java, you know JavaScripts, right? You know Scala or any other, or let's say for example, you know Python. You don't need to know the SQL. Yeah, you can use a Snowflake because JavaScripts also requires to execute a code onto an compute resource, right? So Snowflake supports the JavaScripts is in terms of stored procedures, right? We will wrap a SQLs around a JavaScripts and call those JavaScripts inside a stored procedures. And that's how this has been executed. JavaScript, to my knowledge, not many people in the Snowflake world knows about a JavaScript. If you know the JavaScript, you will be a charm. Why? Because you know how to write a stored procedures. Because the Snowflake hasn't come up with a SQL stored procedures. How does an Oracle supports using a declare and cursor function? Snowflake hasn't come up with that kind of a stored procedure. They still be working on it. They might come up, But right now, JavaScript is the only way to execute the stored procedure. Why? Because JavaScript is more reliable, right? Also, we can do multiple functions using JavaScript. All the looping, branching, everything can be done through a JavaScript in the Snowflake. So that's how the Snowflake handles. Now, coming on to the, let's say, Santosh knows Python very well. Santosh says that why would I write it in a SQL? I will write it down in Python. No worries. Snowflake is allow you to execute a Python workload or the Python programs directly on a Snowflake compute. It does not need to go to the other compute. Means like you don't require a compute to execute your Python. You don't require to create a virtual environment for running your Python. Right? Python runs with a virtual environment. You don't require it any longer. Similarly, Java. Somebody who knows Java, they compiled the functions jar files, they deployed the jar files. Jar files will be directly executed on the Snowflake. Right? So that's how like actually kind of a skill sets what the Snowflakes provide at the backend. Right? Any questions, guys?
One question. So you are referring the clusters and the nodes, right? So is cluster means a data warehouse, or within the data warehouse there will be a lot of clusters?
Within a data warehouse, there will be a lot of clusters.
Okay, so within a data warehouse there will be a lot of clusters, and under the clusters we will have nodes.
Nodes, yes. Under the
So
cluster, we will have a nodes.
okay, so now we are having the data warehouse. Under that, we are having the dev and QA cluster, and those nodes. I mean, within the nodes we can have multiple tables, or how does it work?
So actually the data has been written onto an S3, which is like can be shared among all of these. Now, how are you going to restrict it is done through a role-based access control, right? How you define your roles, how you define your grants, right? That's how you will control your access to that data. So let's say like I
Right.
create a compute cluster, but I don't grant it that compute cluster and privileges to use that data or person who is using it. Actually, it's not like the compute cluster is using it. It's a person who has been given up a grants to use that cluster for their compute and the data, right? So
Oh,
I'll
so
grant
this is
that
only for
roles.
just compute, not for
Yeah.
the the data is available on that nodes or something. No, it's not like
No,
that.
no, no, no.
Okay. Okay.
That's what a Snowflake architecture has been different because the data is stored into an S3, that is an intelligent tier, which we will be talking in. But data is stored all on the S3, right? And the compute is separate, right? You create up in multiple computes, but your data is all on the S3. So anyone who has the right permissions can access that data, but accessing that data, it requires a compute. All right.
Right.
So you've been given up a separate compute to access it. That's it.
Got it. Okay.
Okay. Now, actually, this we have already seen it. How what it will be doing is it's powering up a many workloads. Like your workloads may be related to your data engineering, your data lake. Maybe like actually, my organization is investing into a data lake, preparing a data lake. So can my data lake workloads be supported by a Snowflake? Absolutely. Your data lake workloads will be supported by the Snowflake because now actually people are moving away from a data warehouse because data warehouse is a structured way of storing the data, right? And people are going into a data lake where you will be storing the semi-structured or maybe an unstructured data as well, right? Because it's no longer being constrained of creating up a data marts, right? You are no longer being constrained on creating up a data marts. Everybody he wants to monetize their data, so they have a data, they will be putting it onto a data lake. So Snowflake is good with the data lakes as well. It's not only a data warehouse workload, so it can
Um,
use a data warehouse. Yeah.
what is the difference between data mart and data warehouse?
Oh, yeah. Data warehouse is a consolidated it subject. It's not been specific to a single subject area, right? It can
Mm-hmm.
have a multiple subject area data, but your data mart is being consolidated to a single subject area. Let's say finance, right? And marketing, right? And your CRM. These are your consolidated to a specific subject areas, right? Now the data warehouse will be considered all threes, But let's say like my finance wants to have their own usage, that's where we have created up a separate data mart for them, and they can use it. That, but the whole data warehouse will be consolidating all threes. So the data warehouse is not only been restricted to the single subject area.
Okay.
So that's the major difference. Now coming here to your data science workload, right? So many of you knows a Spark, right? You might be using it as Spark on your day-to-day. You might be using up your right AI ML workloads, all right? You might be giving it up and what you say is in the machine learning, right? Supervised learning, right? You might be doing up an unsupervised learning. You might, or let's say, for example, finding out a truck rolls, right? That what is the truck rolls? You want to find it out that how many service requests you have got it up, right? You might be going to predict it from your usage pattern or from your data, actually. So the data is all there. You might be writing up your algorithms in the Spark to do that. So Snowflake allow you to do so. Right? You can write down your workloads and you can predict it up that, okay, how does it been going to give you a number of truck rolls, or right, what will be your model that's being, so underlying the databases, Snowflake, right? You will be bringing your data into a data frames, RDDs, and that's where you will be doing your computation and writing it back to the Snowflake. So that's it. Coming to the data applications. Now, Snowflake has a support to the APIs as well. Like if in real time, let's say I was designing up on a website, right? In a website, I was asked to provide up a customer information. A customer comes in, right, and customer input their information, right, about a call details. Very basic example I'm telling. Right, a customer comes in, you go to the Vodafone website, right, and you put your call number there, your details there, and you do a lookup. Right, what it will do is it will give you your call details. The same thing, right now actually, because the Vodafone is storing that information at the backend in Oracle system now, but these may be a decentralized systems. They are not a centralized system. So although they might be storing up a values there, but those are specific to the particular application. What if we have a centralized workload, right, where we are storing up all the values, and we will be providing a direct connectivity from my application to that workload or to that data. That is how that to be done is through the REST APIs. So that's where my data applications comes in, right? I create it up on REST API and make a call to my Snowflake database at the real time, and it will fetch the data and will display me, right? So that's something is done by the Snowflake's REST APIs, SQL REST APIs, right? Now, coming to your data sharing, right? Me, I'm working in an XYZ company, right? Let's say I'm working in a media company, which is sharing up the data within another media company. So how does it been made possible? It's made possible through a data sharing, data collaboration, right? I will refresh the data at my end, and immediately it will be available to a person who's consuming that data at the other end. They don't have to run the ETLs for that, or neither they have to download the data or send it. Traditional example, right? A Sam, right, who is working as a consultant in an organization, an IT consultant, right? Actually, his organization used to collect the data every day, right? And then in the night, Sam has a process that will run and extract the files and send it to and another organization. So Sam's organization is an IT organization, but they send the data to a lawyers, right, for the processing forward. Or there's an organization who is handling up the lawyers, right? They have the and they access that data. So what the SAM do is it will create an in the nighttime. First, he will run the workload, right? And in the early wee hours, he will create the extract and send the extract. One day, one sweeper was there, right? And he was cleaning it, and accidentally he take it out a plug. All this workload is running on a SAM's computer, assume, right? And he accidentally pulled the plug. What happens? Right? Sam was unable to complete the workload, and he was unable to share the data. What is the repercussion of that? The lawyers doesn't get the information on time, right? They have to delay their practices. Now, if this thing can be done with a Snowflake data sharing, so let's say like in the SAM has loaded the data, right? Or the processes which is running. So first of all, right, Sam does not have to worry about a sweeper taking out the plug because the process is running on the cloud, right? So no infrastructure is on the ground. It is all on the cloud. What is the cloud? It is a X location data center, which is like somewhere or which you don't know. That's why we call it as a cloud, right? Now, actually, that process has been scheduled to run at there, and then as soon as the data has been updated, right, it will be available to the lawyers. Even if the data is available at updated at 3 a.m. in the midnight, the same time it will be available to the lawyers as well. So that is called as a collaboration, data sharing, right? So they don't have to be worried about getting a process breaking down and all that, right? The files not generating on time and all that will go away, right? So that's right, multiple workloads being shared. Now coming on to the data Snowflake node size. Okay, now Snowflake says that, hey, actually we provide you up the nodes with the uh, t-shirt size. How does our t-shirt size work? Extra small, small, medium, large, XL, 2XL, 3XL, and 4XL. Now, actually, they have 5XL as well. 5XL is 256. So extra small has one node. What is one node? Means one CPU of and 8 gigabytes of RAM. Small has two nodes, right, clubbed together, which is having two CPUs and 16 gigabytes of RAM. Medium has four CPUs and 32 gigabytes of RAM. Large has 8 CPUs and 64 gigabytes of RAM. Something in the same way that's been distributed. Now, this is what we are seeing it is a single node. What if we have multiple such nodes, which is on demand capacity, right? When you say that on demand capacity, right, your processes is not running all the time. Let's say like my VPs and all my CIOs comes in the morning and they want to see the same report and all are running the same report in the morning, right? My capacity has increased, right? So at that time it will spin up another cluster of the same size or another node of the same size, right? And then it will be using up that node. All right. So the processes has been distributed because of the increase in the in the capacity, means increase in the demand. The capacity will be created on the fly. All right. So your processes will be distributed among those two. Now, this all you can define it. Wow, you can define it when you will be creating up the warehouses. In the Snowflake terms, it is called as a virtual warehouse. When you will be creating up a virtual warehouse, you can define it and say that, hey, I want to create it up in 10 cluster warehouse. All right. Now, actually, with extra small size. So, and how many clusters you want to run together? That also you can say that, hey, I want to run and all the times two cluster. All right, or I want to run only one cluster. Now, another feature, right? If you are not using that, it will shut down. So like step and go kind of a feature. In the cars, it's now very much popular, right? Actually, which is called as a step and go, right? If you stop at the red light, your cars will stop, right? As soon as you put your foot on the accelerator, the car will start and will go. So this is something like a step and go feature. So as soon as you submit your query, it will start using up the compute. But once your compute query is completed, it will shut down after X number of time. That you can define it, saying that, hey, actually, I want to shut down my compute after 1 minute. I want to shut down my compute after 5 minutes. Now, Snowflake says that we will charge you per second billing. If you are using an extra small node, we will charge you up for 1 hour. If you are using that node, 1 credit. But that does not mean like actually it will not charge you if your queries are running less than 1 hour. It charges you for per second. So you divide that 1 by 60 and you will find it out that this is the per second billing charge. For very first time you will up and run your or cluster, right? It will charge you for 1 minute, and then after that it will charge you per second. So that's how the Snowflake will charge you. So you don't have to worry about too much of charge. Why? Because you are paying it for what you are using. If your query run for 2 minutes, you will pay for 2 minutes. If your query run for 1 minute and 30 seconds, you will pay for 1 minute and 30 seconds. Even if your query run for very first time when you submitted your query run for 10 seconds, but you will still be paying it for 1 minute, because for first minute, it will charge it for 1 minute for first time when the node is up, right? And after that, it will be all per second. Right? So this is something, how does a Snowflake will distribute their compute. Any questions? Okay, now another thing is Snowflake supports scale up and a scale out. What is the scale up? Scale up is creating up multi-cluster warehouses where, like, actually on demand the capacity has increased, right? I will spin up another node and will allow them to work on that node as well. Let's say, like, actually I have a family of 3, right? My cousins have joined, right? And I have a small car, so we cannot go on a party all together. What I did it is I have ordered up an Uber for them. Now, actually, I will take my car and they will go by an Uber, but Uber is also the same size, and we will be paying up for the economy rate for that. So that's something in just a correlationship of the example which we are giving. But also, it will allow you to scale out. What is the scale out? You can change the size of your warehouse. You are not limited to use only extra small. So let's say you are running your SQLs, right? Currently, with the extra small size. Tomorrow, your data volume has increased and your SQLs are taking longer time. You realize it that, hey, actually my workload is also increases. Can I change the size? Yes, you can change the size on the fly as well, right? On the fly means if your queries are running, right, and you change the size from extra small to small, will it make an impact to the existing query? No. To the new query, yes. The new queries will start using up a small size warehouse. So that's how that the small the scale out versus scale up will be differentiated. Scale up is multi-cluster. Now actually you will be creating up multiple clusters of the same size. So this is extra small is the size, right? So extra small is the size, right? If it is a scale up, you will be creating up a multiple cluster if your workload is increasing. So scale up is a dynamic. Scale out is not a dynamic, right? Scale out, you need to configure it. You need to say that, hey, actually my query workload looks like has been increased. I want to change my size from extra small to small. You can do that. So this is just another example, right, which is showing it up that how does it, and medium one cluster, extra large one cluster, and medium 1 to 4 clusters is been costing it up, and the output and the cost, right? I think so. When I was running up my queries earlier, on the medium 1 cluster, my workload was low, right? Actually, and the throughput was also good. Means like I was running up 3700 3800 queries, right? Actually on the time. Now actually, what happens is my query response time or queue time is more. Why? Because my queries are queuing up because they don't have the enough of resources. So what I did it up, I change up the cluster from a medium to an extra large. What it did it has increased up my throughput, right? Number of queries are increasing, but I still see the queries are queuing up. Why? Because it is not getting, because my queries, number of queries has increased, but although like actually I still be not able to get enough of resources to execute my query, right? So I'll still be seeing up the queuing. You can see that this is also queuing it up here. The pink color graph which is showing it, right? Magenta color. Now the cost, in terms of cost, since I moved from medium 1 cluster to extra large 1 cluster, my cost is also increases, right? Because my cost has been doubled. Every time you will change the cluster, the cost will be doubled. So what I did it is I created medium 1 to 4 multi-cluster warehouse. Now what it did it is, whenever like there is a new query that comes in and doesn't find up a resources, it will spin up in another cluster. And now my throughput has been increased 3 times, close to 3 times what I had it earlier. Now I have been running 9,000 queries at times, right? Now my queuing is happening? No, I don't see any queuing which is happening. And what is my average cost? Average cost is $27 that is coming out. So this is for running medium 1 to 4 multi-cluster warehouse, with 8,686 queries running. The cost is $27. Right? So this is just just to give an idea. Like, any questions, guys? Okay.
No.
Let's move forward. Like, all right, this is again one another example, right? How does this capacity is going to work? The small, right? We have multiple queries, right? Which is running. You can see that multiple dots here, right? Actually, I have the different kind of queries, right? Now, actually, if this is running on the small, right? It will run for a longer duration because the queries are queuing. This is the queue, right? The query queuing up. Right? I submitted the query, but query does not have the resources because I'm running up a small. Then I go with the medium. I still see that my resources are getting queued up, right? But when I go with the medium two cluster warehouses, I see yes, both the workloads can run parallelly. Now, actually, this is one workload, right, handled by one workload, and this is another one. So now, actually, this is just a single pipe, or you can say the single channel, right, from which the queries are running. So there might be the possibility that the queries may not get a resource or may not get enough of time or something. Right? You increase the size means you increase the size of your pipe, but still you will see there is a problem. But what you did it is you created up a two pipes of the medium now. So now you will have the lesser time, right? The flow will be faster, and you will have a lesser time as well, right? Compared to the, so this is how like we decided it out, right? Actually, how when is the good time to increase the capacity. That will, in the initial, you will not see that impact. When you will complete your migrations or when you complete your implementation, right, and when it is started using up the compute, then at that time you will need to understand it, right, whether I might be using up a correct size, or I might need to increase up the size, or I might need to create up a multi-cluster warehouses to, so that my jobs can work faster, right? And this is the same. Now talks about the key performance services. So Snowflake, how does it mean about giving up the optimal performance? What we required is because of these three services, which is called an automatic clustering, materialized views, and search optimization services, right? What is the automatic clustering? It is basically a Snowflake way of distributing the data. Now Snowflake use micro partitions for writing their data. So this is an automatic clustering. It means it will cluster the data whichever is been in return by an process, ETL process or any other process, right? It will do the reorganization of the data on the basis of that particular key, right, into a micro partition, so that when the query comes, it should know that my like data is present in this particular page. So consider this as a page, right? When you are writing up your information on the notebook, you are writing it everywhere, right? Let's say for initial, you are taking up a notes, you are going to put it up everywhere. Then you realize it, hey, actually my notes is everywhere. What should I be doing? You rewrite those notes with the topics, right? The particular topics into particular pages. So that's how the Snowflake do it, right? You understand that, hey, actually I need to have the redistribution of the data. My data is all over. So what you do, you create up a clustering key, and then the Snowflake will take care of the distribution of the data at the back end. Right? It will organize the data at the backend for you, so that your query is, when the query comes, will know that, hey, actually I don't need to scan it up this particular topic. It is of no use to me. It will go and scan only the particular topic. That's what called is an automatic clustering. Coming on to the materialized views. What is the materialized view? So Snowflake, and not in Snowflake, even in the other cases, right? We do on commit preserve rows, right? So what is an on commit preserve row? We create a view, right? We can do the calculation, and then we will, when we insert it, we say that on commit preserve. So it will preserve those calculation. But in the Snowflake world, what it do is you define a calculation once, right? Any new data that is added, the Snowflake will automatically calculate it and store it, that data, for the views, for views to consume. So those are mainly for your aggregation purpose. Let's say like I have a table, fact table. I have inserted a rows in that fact table. right? And then the Snowflake, we create up a materialized view. Now, Snowflake will only allow to create up a single table materialized view, right? I created up an aggregated fact table, aggregated materialized view, sorry. So I don't need to redo the calculation every time my fact is updated. The view will be automatically updated at the backend by Snowflake. So Snowflake will have the details of the aggregate table. So it is not going to take a longer time as well, because right, what happens is generally when you define the calculation, it will run the calculation. No, Snowflake will pre-calculate that and come and put it in the storage partition for you to access it. Whenever you come, you can see the data. So new data whenever is added, it will pre-calculate that pre-calculate the aggregate and will make it available to you. Right. Now, the third one is search optimization. What is the search optimization? Let's say you have a big table, right? Now, actually, this is the place where, like, actually, you are looking it up for a specific information on a specific person. Let's say you are looking it for information on Anshul Agarwal. So what it do is it will allow you to enable a search optimization services, which will allow you to find it out in quick direct path to the Anshul Agarwal. So you did it search optimization on a name. So what it do is it will create a direct index in the Oracle term. Right? It does not create an index. What actually it do is it creates a direct path to that data set. Right? And whenever you search for a specific name, it will go and look it into that data set and will get you that data as quickly as possible. So it does not have to scan all the pages to find that information. So like how we will store that information in our indexes, right? In the notebook, right? You have the indexes or the glossary, right? So you look at the glossary and then it will find the information. So this is something with that kind of a service which will allow you to do the quick search, the search optimization services. Any questions, guys? Okay, this is the automatic clustering. I know actually we can talk more but with the time constraint, and we don't want to take it up that into very detail. Right, in the classes, these topics will be covered in a very detail. Right, we will talk about these topics and all. Right, materialized views, how the materialized views are created, how does it can be used, what is the cost implication, how does the search optimization works, right? Then the match recognize. What is the match recognize? How it's been useful, right? So this all we'll be going to talk very detailed during the classes. Is right on the regular basis when we'll be interacting, right? On geospatial data support, how you can use up a geospatial data, right? How it can be supported, right? You can store that information inside your database, right? Actually, the location, your latitude, your longitudes, right? All that thing, well-known test, right? Well-known binary text, right? Spherical mode of data, right? All that can be stored inside the database. You don't need a spatial algorithm to calculate it. If the data is coming in like that, it can be stored, right? So all these things, geospatial data support. Now, the main thing what we want to talk is the snow site. What is the snow site? So every for accessing an Oracle, what we use SQL Developer or a Toad, right? Snowflake has their own UI. You don't have to worry about bringing up any of the tools, right? It is free of cost, this own UI. So there are two UI, which is called a classic UI and a snow site. So now what does a snow site gives? Snow sites provides you an interactive way of creating a dashboard on the fly with your data, right? You query your data, you want to visualize that data. Yes, with the Snowflake, you can do it on the fly. You don't have to go to the Tableau or MicroStrategy or any other reporting tool, in fact, to visualize that data. You query, you can visualize, and you can share. So that's how like the Snowflake is. You find your data, you analyze your data, and you manage your data by sharing that data. So that's the Snowflake way of providing in your data access, right? Now, similar, all right? Actually, just a few more features about the snow sites. That actually it's a fast and responsive querying method, because if you write down a query, you know that you are using this particular column or this particular table, right? It will auto complete it. It will provide you an option to auto complete. Means you can use a tab to autocomplete. It will give you the quick search option, right? Then, and it will provide you don't have to write down and multiple queries, big queries. Why? Because like I have written a query, I shared with Santosh. Santosh can and use that query on the fly. Means like actually that query will be shared with Santosh and he can directly use that query. He does not have to rewrite that query, right? Now, actually, there are multiple other things as well, like the interactive results. What is the interactive results? You can create a dashboards out of that results, right? You can preview the results. Right? You don't have to preview the table results. You don't have to write down the complete query or select a star to preview it. It will show the stats. What is the min value? What is the max value? Right? All that kind of stats will also be available on the data, right? Then the charts and the dashboards, is you can create a chart, you can create a dashboard. Now, one another important thing is the filters. Let's say like I want to use up an query for a month filter, right? I have a 10 users. So what I did it up, I created up and filter for them. So what they have to do is they don't have to pass the dates again and again. They can use that filter. So I created that at the admin level and that filter will be used, right? And the other important thing is sharing, right? You can share the queries, you can share the dashboard with your team members and they can view it, they can run it. You don't have to extract it out or create a report or sending it across. That's no longer been required. It's called collaboration, right? That's one of the feature of the Snow site, right? Now, any questions, guys? All good. Okay, coming on to the Snowpark. Snowflake has not recently, I say that in the last year, in second quarter, they have rolled it out as Snowpark. What is the Snowpark? Snowpark provides you a capability to use any of the programming language because not many people are good with the with the SQL, or they don't want to code it into a SQL because their familiarity with their own language is much more than the SQL. They don't want to get into a SQL side, right? Like our friend Kumar doesn't wants to go on to the SQL, but he knows JavaScript. Let's say, for example, if he knows us Java, right? So it will be easier for him to write down a Java programs executing on the Snowflake and perform his work rather than learning up a SQL and performing. Maybe like in the Java, the same thing what we are writing in a SQL in 10 lines, he can write it down in a one line, right? So that's basically because of his understanding with the language. Now the Snowflake is enabling us to use those language directly with the data which is present in the Snowflake, and that's been made possible by Snowpark. We will not be covering the Snowpark in very much detail in our course. The reason for it is, right, actually, I can cover it up for the Python. I can cover it up for something for the Scala, but I don't know, like, actually the background about you guys, right? If I have to teach you in a Scala, it will be a complete separate class, right? If I have to start with the Python, it will be complete separate. If you know Python, definitely you want to try it out. I'll help you up in learning up the Snowpark more. If you know about a Scala, I'll help you up there in taking up that Snowpark to the next level and to use the Snowpark, right, to take your learning to the next level. So that's something, right? It is for the on the own interest, right? I just want to ensure it that Snowpark by Snowpark, you have the capability to write your own programs in your preferred choice of language, which is Java, Scala, Python, right? Which is means right now Scala and Python is supported. Java is coming up as well. You can write down in Java, right? Okay, now that's with the Snowpark. The simple example, right? This in the Scala. How does it been written? See where the value is equals to data frame session dot table. This is a particular syntax. I write down a table name dot filter that on the column ID equals to 1, where select a star from product where ID equals to 1. That's how this has been written in a Scala. That's how this has been written in a SQL. So this is something like actually in the native data frame. The data frames is again actually in terms of a Spark or Python, right? It's a native way of storing up the data in the columnar format. That's called as the data frames. Okay. Now, let's not data frames. That's just an example, right? Actually, data frames is supported in Java, Scala, Python, right? Where the queries you will use SQLs, right? Which is a declarative language. You need to write down the query saying that select a star, this column, or select this, right? Which is the functional languages, right? Java, Scala, and Python, right? Again, example, just an example way of doing up, right? Concise syntax. It's having a more efficiency. You don't require to do too much of coding, right? No binding of the variables, right? No binding of the processing engine, because all these languages require the processing engine. Now, where does this processing power comes from? That's come from a Snowflake compute. That's where, like, actually the Snowpark plays a vital role, right? It will allow you to execute this program on a Snowflake compute rather than being relying on or creating up a separate compute like a Databricks. Databricks, what does a Databricks do? It will create it up a Spark cluster for you and will allow you to do the query. What is a Databricks? Databricks is a similar tools like in a Snowflake, where it will be using up at the hood, also doing up the same kind of things what a Snowflake is doing. Okay, but it's mainly popular with the machine learning or a data scientist, right? For their for because of their Spark compatibility, because the Databricks has been built on the Spark natively. Now, actually, talking about the Java functions, how does the Java functions will work? So Snowflake will support the functions. Now, actually, let's say I have created up a time function. All right. What I did it is I created that time function in Java. I created up I compiled that. I created up a JVM with the JVM, right? And I created up a jar file, let's say, for example, right? And I want to execute that jar file through my Snowflake. So whenever like actually I pass upon a time, it will calculate the time and it will display me all the three time zones, mean UTC. It will display me the Eastern time zone and the Pacific time zone. All right. So I have written up a function which is in the jar file, compiled it into the jar file, created up a function. So whenever I am calling that function, it will be producing these three values. Now this function is written into a Java, which has been executing via JVM, which is present on the Snowflake compute cluster. So that's how this has been supported with the Java functions. Right. We will talk about this in more detail. Right, see some of the examples of the functions. Right, how does the function works? What are the different types of functions? Right, that has been used into a Snowflake. Right, now some of the external functions. Right, if that's up to you guys, right? If you want to learn about an external function, which is something like you created up a function which is deployed on the AWS or Azure instance, where you will be using up an Azure and AWS to to call that particular function. That's where you can give a call using in an external function by creating up an API gateways and all. Right? Actually, we don't want to go into much that. This is an advanced level again, right? If the time permits and the course permits, we'll see that. But otherwise, just to let you know that it supports the external functions as well. Anybody who has created up a function, or let's say like somebody who has created a function for converting in the email, scanning the email written in English and converting it into Cantonese, right? Right. So Cantonese is a Chinese language, right? So what I do is I have written an external function, deployed that external function on Amazon Web Services, right? And the email is contained as an input in my Snowflake. So when I run that, I will pass on that particular column which is containing the email content, and it will convert it into a Cantonese, right? Which is a Chinese language. So that's just been done through an external function. That function has been residing not in a Snowflake, it is residing in an AWS. Any questions, guys? All good. Actually, I don't hear it up anything, guys. Please feel free to ask me if you want to ask anything. Okay, so let's move on to the APIs. Now, actually, recently Snowflake has rolled out an API support. What is an API support is, right? We saw that actually using Postman. You know, the Postman has been developed by an Indian And actually, so we whenever like we create up a program and we want to do an REST API calls, or maybe like actually we want to search it up from the website some information and all, right? Kumar, I think like you might be using up a REST API more than and me or anybody else. I don't know, but you might be doing up a lot of REST API calls,
Right,
right?
right. Mm-hmm.
So now actually think of this as in like your data has been stored into an database, right? And you want to quickly look up that data. What you can do is you can use the SQL APIs. Right? The SQL APIs, what it will allow you is to write down those SQL queries, right? Which will trigger via an API, the REST API based means REST API based method, make post or get, right? And you will get your result back from a database immediately. So that's what the Snowflake has did it. It has encapsulated its SQL with the REST API based calls, where my application REST based applications is being used. I can make a REST API calls and it will do it up. So you can see that, right? Actually, this has been, that's where our service now is going, right? Because of the introduction to the SQL APIs. Right? So now actually the service now who can use those SQL APIs directly to query to that data which is stored into a database. Now actually what other advantage to that is, because it will provide you an unlimited compute, it will provide you an unlimited storage. You don't have to worry about scaling your compute and storage, right? You will just deploy it once and forgot it. Right. If you see any challenges, right, on the compute side, what you will do is you will scale out. You will change the size. Earlier you deployed it an extra small. Now you will deploy it up and a medium size, which you know that can handle it up this much of the workload. So like that. So that's why ServiceNow is considering the Snowflake route, going through a Snowflake route, right? No, actually, that's with the SQL APIs. Any questions? Any other questions, guys? Now, actually, you might be wondering, right? How will it be throwing up and semi-structured data or JSON data? Snowflake has a native support for an JSON data for a semi-structured data. So it can query. You can query to the semi-structured data, which has been stored in a JSON format in a database, right? You can query that, and it will throw the results out. Right. Actually, in fact, like any structured data which you are storing in a database can also be constructed into a JSON format, right? So that can be also thrown as a JSON output. Right? So Snowflake provides those functionality to convert your output into a JSON format. Okay. Coming on to the intelligent infrastructure. So far, right? Actually, we have covered it up about the compute part of it. Now it talks about the structure, the infrastructure part, which contains about your the storage mainly. Right? How does it mean a Snowflake is managing all that storage? In fact, as well as the compute as well. Right now, let's say like today, i7 is the most predominantly used compute. Right? Let's say tomorrow, i7 Tiger Lake, right, which is called i7 1153, right? So that's now actually comes in. So you don't have to worry about it, right? A Snowflake will take care of it for managing that at the back end, right? How does being a Snowflake is managing the clusters? There is a high possibility that when you spin up a cluster, one of the cluster may go down. So Snowflake has the metrics running on top of every time, right? The new cluster will spin, it will monitor for the performance. If any nodes goes down, it will replace it immediately. So that is what a Snowflake has, the intelligent infrastructure running at the back end to support your needs. It will never happens that your data will not be available to you, right? In all the databases which I have worked, I have seen, right? You always require a downtime for your maintenance. Snowflake does not require a downtime. It will always be up, always be running. That's mainly because of the cloud infrastructure on which it is running, right? And because of the Snowflake intelligent and tiering, which it did it with that cloud infrastructure. What it do it is taking care of your maintenance, of your tuning of your data, right? It take care of the administration, which requires your backup of the data, made your data available all the time, right? You Then it requires a data management, means like it will be letting you know that, hey, actually you have this much bytes of data written here, right? This is your table storage size, right? All that information. Then the multi-cluster and compute resources, which says talks about it. If in case if you need compute, if your workload has been increasing, you have number of users that is increased, you can increase the clusters. Then your networking and encryption. Now, since your data has been moving to the cloud, right? Everybody has the conception that, hey, actually data on the cloud is unsecured. Why unsecured? Cloud data is more secured from your on-premise data. On-premise data, I can go and plug in a hard drive and put a virus inside it. On cloud, it is not possible because even and right, AWS CEO can't even go into a data center. They require a particular access because everything is been done there via robotic arms. For every single thing has been done with a robotic arms. It is self-managed data centers. You don't need to step in into there unless until it is very much of the problem. Then you will step in, but otherwise there is not an instance that where you need to go in. And every instance is recorded and monitored because your whole data or whole application has been sitting and residing there. So it should not be allowed or controlled by anybody or accessed by anybody. And that's why now coming to the encryption part, right? All data in a Snowflake is been encrypted. How does it been encrypted? It is encrypted with tri-key secret. What is a tri-key secret? Consider that you have a big lock, right? In your house, you have a lock that will require the three keys. Two keys for that lock is with a Snowflake, and one key is with you, right? Unless and until you put your key, the lock will not be open. However, the Snowflake will try, right? So that's something. It's in the encryption is a lot bigger topic. We have discussed about that. How does the Snowflake supports encryption in transit, encryption at rest, right? Actually, what are the algorithms that is been supported for encryption in transit? What is the algorithm supported for encryption at rest? Then comes about the centralized storage. So all this data is available in an S3 or a blob storage, but these S3 and blobs are not accessible by anyone other than the Snowflake program, right? So you can't go and access that storage at all. You can't see those files as well. How those files is, even in Oracle, if you go to the hard drive, you can see the files, right? I don't know, like you cannot see the data because the data is in binary format, right? But again, you can see the file and you can decode it. Not a big task. You can decode it if you get to the file. In a Snowflake, you can't even go to the file as well. Even if, let's say, like actually, I might be some kind of a hacker or something. I reach it out to that storage. I can't see the data because the data is all gibberish. Why? Because the data has been encrypted with three keys. So that's how that a Snowflake will achieve it. Then actually the cost is the important factor, right? See, consider, right, actually idling on sitting in your car and idling on the traffic jam, right? What it will do is it will shut down your you will keep your engine running, right? Because your traffic is moving slow, you still be stopped, your engine is still running. A Snowflake says that don't worry, as if you are not using it, your compute will shut down. When you will start using it, it will come up immediately, right? So that's how that the Snowflake will manage up the cost as well, right? So it will have the fine grained control on the cost as well. You can decide the size what you want to do, use the size, right? So that's just some of the intelligent infrastructure. We'll talk about it these as well, right? Then uh, the other thing is Snowflake also supports up the caching. What is the caching? The Snowflake has three level of cachings, right? The metadata cache, which is resides on the cloud services layer. So in the Snowflake infrastructure, there are three layers, right? First is the cloud services layer. Second is your compute layer, and third is your storage layer, right? So your metadata cache resides on your or sorry, the metadata cache resides on your or the first layer, the cloud services layer, all right, which will allow your see, let's say if I run the count star, all right, it does not even require the compute if I run a count star, because that information is present in the metadata cache, right? So it is already cached. What is the minimum and maximum value? It is already cached on each column, minimum and maximum value, number of distinct values. So these all things is already cached and stored. Second thing, right? Let's say like when and how does this cache has been useful, right? Because when you submit a query on a Snowflake has to know that where this data is been written and what information has been written on which micropartition it has to be. So let's say taking an example from your notebook, and you are reading it from your notebooks, your notes, right? If you know that the index number, you will no longer need to scan it up all the pages. You will directly goes to that page number. You will directly goes to that paragraph number. That's it. So that's how does that happens? The Snowflake is storing all that information into a metadata cache, which is stored in the cloud services layer. Second is your data cache, which is stored in your virtual warehouses. What does it means? Right? Let's say like you have run the query, right? And you have bring up all the data for that into a RAM for compute purposes, right? And your warehouses will still be running, and somebody else comes in and run the same query, which is using the same table. So what it do is, instead of scanning up that data from the disk, it will say that, hey, actually, hey, Anshul is also running the same query on same compute node, right? Why not I take advantage of that data which is already resided on the compute node right now? So it will go and fetch that data and will calculate the result on the basis of your query and give it back. Because anyways, you have to bring your all data to your compute node to do the calculation, right? So this is what the database cache is, right? So it will stores in the virtual warehouse memory. It means like Snowflake also has an SSD attached with each compute. It is not only a RAM, it also attach an SSD. So 256 GB of an SSD is attached. So every time you scan the data, it will become and put it into that SSD. Right? So now actually if I submitted a query when my compute has been running, right, it will go and fetch the data from that SSD. As long as my compute is up and running, that data is available. As soon as my compute is down, that SSD has been destroyed. It's been returned back, right?
Anshul, I
Yeah,
think I have to drop. So
yeah, no problem. You just been completing up. Thank you very much for your time.
thank you. Mhm.
Take care. Bye bye. Okay, now that's the third one is a query result cache. What is a query result cache is? Basically, it is storing up the query result which you have. It means like the query which you have executed, it will store the result for 24 hours. So let's say in 24 hours, if my table hasn't changed, right, and my query parameters hasn't changed, I come back and re-executed the same query in 24 hours. It will, instead of doing up all the calculation, it will scan it from the cache and give me that result back. Okay? That is called as the result cache. Okay, that is stored in the cloud services layer again. Okay, so these are the three types of caching in the Snowflake. Right. This is just about the micro partitions. We'll not take much time on the micro partition. I know this is the deep topic which I want to cover it up, but the other features also would like to give you a little overview. Right, what is make a Snowflake distinct from the other databases, which is one of that is a zero copy cloning. The cloning feature will allow you to clone your data without actually moving your data. It is just cloning of the pointer. So you see, right, I have a dev pointer, right, and I want to use that data for my other project, right? Like say, for example, in my QA project, I have a data which I want to bring for my prod. So I don't need to do a data copying. What I do is cloning. What does a cloning will do? It will create a pointer to that data set and will make the secondary pointer to that data set and make that available in the metadata layer. Now, any new data that is added will be respect to that particular environment, means like to the QA environment, because it is not going to be updated, or let's say like the pointers are created for a point in time. Very detailed topic. Very good. If I want to explain you up in detail, but for now, think that as in a pointers game, right? You don't have to worry about it. At the under the hood, Snowflake will take care of about creating up the pointers and all, but it will allow you to create your databases with the data in seconds. It does not requires the long process of taking up a backup and restoring a backup or creating up the databases, inserting a data. No, it's all gone with the zero copy cloning, right? So that's just an example of a copy cloning. Another one is a time travel. We will have a lot of examples when we will be going to do an time travel, right? What does the time travel do is, let's say like you are loading your data from 1st Jan, right? I have set up my time travel for 14 days. Now actually on 13th of Jan, I realized that the data what I've executed on the 1st of Jan is wrong. And what I did it is I created up all the historical records after 1st of Jan because I'm daily loading up that data there. So the instance will be created daily. So whatever Snowflake give us the flexibility is to go back to that point in time when we first created that table, or maybe like when we first started inserting a data on the 1st of Jan, we can go back to that time and restore the table state on that time. Right? We don't have to do any deletes or anything. It is just right going back for a point in time to get that state of a table state and that time frame. So that's all being possible with the time travel, right? So that's how the Snowflake do the time travels. We will have the examples as well. I don't want to cover it up. I know, right? It's already been too late, 2 hours, right? Just want to wrap it up quickly. All right. No, actually, security is at the multiple levels on the Snowflake, right? Actually, we'll have the full details about the securities when we talk about it, mainly focusing on. I'll also introduce you about the tri-key secrets, right? How the tri-key secrets works, what we do with the tri-key secrets, creating up your duo authorization, the single sign-on, all right? Then how you can implement a role-based access controls, right? Those we will be covering it in the security lectures, right? This is a tie key secrets which we talks a lot about it. And bring your own key concept, right? Customer own key and a Snowflake key, master key, right? Then how does the data protection in the Snowflake works, right? When against the corruption and of all that, that's been all supported with the intelligent tier, or means like intelligent tier in terms of the intelligent storage, right? The storage has been replicated into 3 zones. So if in case if your one storage is corrupted, it can always be retrieved from the other zone. But again, the protection of this, it is not only with the data, right? How the data is being accessible, right? Actually, you can also have a multi-zone deployments. I mean, not multi-zone, multi-cloud deployments. So you can have your Snowflake instance on AWS where you are inserting your data. Tomorrow, your company come and say that, hey, actually, I want to have the DR strategy. You can replicate it on the Azure instance, that same data. So it will be as a DR, means disaster recovery database will be created in the Azure instance. So in case if AWS goes down, your data will be accessible by a Azure instance. Not both can go down in the same time. It's not highly unlikely, but just that's the database application and failover which I talks about it, right? Actually, in case if you want to do up and multi-cloud database application, Snowflake supports that as well, and we will see in the exercise some of those things. Not very in detail, but again, in we can see that, right? Okay, now actually coming on again to the structured data support, we support all the semi-structured data, JSON, XML, Avro, Parquet, ORC. We will have an exercises with the JSON data, specifically and complete class within JSON data, where we will be seeing up how we will be flattening, first storing the JSON data, then we will be flattening the JSON data, right, and getting an insights out of the JSON data. And some exercises will also be given to the team or to the attendees, that how they will have to they'll have to do it themselves, and then they'll have, if they have a challenge, definitely I'm there to help out in that case. But how the Snowflake is storing that data, right, at the back end, right, what data types Snowflake is using, what are the predominant data types available with the JSON or semi-structured data. We will talk on that in the detail, right? Some new feature that has come in, right? Actually, I don't know, like if I'll tell you of that, it is something in which is right now in the preview mode. It's not been rolled out, which is called as a schema detection, right? As soon as you write down your semi-structured data, Snowflake will identify the schema of that data and will also help you creating up the schema on the or will help you, not the schema, sorry, it will help you creating of that table with that particular definition of the data. So the Snowflake provides that particular capability, which is called as a schema detector. Very new feature, recently been rolled out. Not many people knows about it, not many people using it, but it's very good. All right, actually, because our all data is in the semi-structured format. So if we'll get to know the structure of that data without having to ask somebody, super, very easy for us to create up the structure and then load that tables inside that. Right. Now, actually, Snowflake also provides up a Snowpipe, which is for your auto ingestion of the data. We will be doing an exclusive exercise for the Snowpipe for the auto ingestion. We will create an S3 bucket, we will put the data there, and it will be automatically loaded into a Snowflake without using of any of the ETL. Okay, that's called as a Snowpipe. So how does a Snowpipe works? How we will configure the Snowpipe? We will be going to see it in the lab. Right. So that's all I want to have it, guys. I'm now open for the questions. Right, please feel free to ask me any questions you have. No questions, anyone? Dhruva, Jagdish, Jagan, Ramesh, any questions, guys? Okay, no questions, then I'll conclude it up this webinar. Thank you very much, everyone, for joining, and wish you have a wonderful weekend. Right, and related to the classes and all, you can talk to Shinu. He will be coordinating all the classes. Right, he'll be happy to help you up with the details on the classes. Thank you very much for your time. Have a great weekend. Thank you, guys.